So today we start with very important topic, that is define 1 calorie. First of all, 1 calorie. How you define 1 calorie? 1 calorie is defined at 14.5 degrees centigrade, 14.5 degrees centigrade to 15.5 degrees centigrade. The amount of heat needed to increase the temperature of 1 gram of water from 14.5 degrees centigrade to 15. Amount of heat required to increase the temperature of 1 gram of water from 14.5 degrees centigrade to 15.5 degrees centigrade is called calorie. 1 calorie is equals to 1 calorie is equals to 4.2 joule. One calorie is 4.2 joule. Now देखो इसमें कुछ definitions है. These are very important definition. First one is the specific heat capacity. Heat capacity. It is represented by the symbol small c. From the definition, actually what you have, del Q, that is mass specific heat capacity, del T. Mass specific heat, del T. So what is my C? C is 1 by m del Q by del T. That is my the definition of specific heat capacity. Specific heat capacity is defined as the rate of change of heat per unit time, per unit temperature, per unit mass. So what is the SI unit? SI unit is joule per kg per degree centigrade, or joule per kg per degree per Kelvin. So both you can use centigrade scale or Kelvin scale. Specific heat capacity. After specific heat capacity, some important point about the specific heat capacity. Specific heat capacity depends on the nature of the state. Like depends on nature of the state. Depends on nature of the state. देखो सेम वाटर का डिफरेंट स्टेट में डिफरेंट स्पेसिफिक हीट कैपेसिटी होता है. जैसे आइस अगर है, आइस है, वाटर है और स्टीम है, तो अगर हम इसका CGS यूनिट में देखें तो आइस के लिए होता है 0.5 कैलोरी पर ग्राम पर डिग्री सेंटीग्रेड. वाटर के लिए होता है 1 कैलोरी पर ग्राम पर डिग्री सेंटीग्रेड. स्टीम के लिए होता है 0.47 calorie per gram per degree centigrade. So the first important part is, if anyone asks you for the same material for different step, is it different or same? So the answer is different. For different state means solid state, liquid state, gaseous state. For water, specific heat capacity is different. That is very important thing. Second very important thing is if a substance is undergoing change of state. Yes, if the change of state happen, change of state. See, if you use your basic dimag, which is say change of state means no change in temperature. So whenever your change in temperature is 0, कब कब हो सकता है? One is the change of state, one is the isothermal. So change of state and isothermal process, your del T is 0. If your del T is 0, so specific heat capacity is 0. So they can ask you this type of question. Another one, adiabatic process. In adiabatic process, we all know del Q 0. If the del Q is 0, so specific heat capacity 0. Oh, I am sorry. This is 1 by 0 is infinity. Specific heat capacity is infinity. So for change in state, specific heat capacity is infinity, and for adiabatic process, specific heat capacity is 0. Is it okay, everyone? Everyone, is it okay? Acha, specific heat capacity can also be negative. See, specific heat capacity can also be negative. Negative specific heat means that for increasing the temperature, heat absorbing or that is decreasing. When del Q is decreasing, for increasing the temperature, del Q is decreasing. Negative specific heat means that in order to raise the temperature, a certain quantity of heat is to be withdrawn from the body. हम लोग temperature बढ़ा रहा है और वो heat withdraw कर रहा है. Okay, specific heat of saturated water vapor is negative. Example, saturated water vapor. So these are informative type question. Specific heat capacity of saturated water vapor is negative. After that, next is molar specific heat capacity. Molar specific heat capacity, which is represented by capital C. So how you define molar specific heat capacity? Del Q is equals to N, number of molar specific heat capacity, and del T. So I think you understand the difference. Mass specific heat capacity del T, that C is the specific heat capacity, and instead of mass, if we use mole, that is called molar specific heat capacity. So how you define molar specific heat capacity? Molar specific heat capacity is defined as per unit mole exchange of heat per unit temperature. So what is the SI unit? SI unit is joule per Kelvin per mole, and CGS unit calorie per degree centigrade and per mole. Okay. Now this specific heat capacity is two type. You know very well. I already show you. Specific heat capacity is two type. One is the CV, one is the CP. So 1 by N del Q by del T. If my volume is remain constant, then it is called a specific heat capacity at constant volume. And if my pressure is remain constant, then it is called molar specific heat capacity at constant pressure. And the rest we all know, Cp minus Cv equals to R, Cp by Cv equals to gamma, that is 1 plus 2 by A. We know all these things. Okay. Apart from that, you have a very interesting thing, that is Dulong and Petit law. Dulong, D-U-L-O-N-G, Dulong and Petit law. Dulong and Petit law. What is Dulong and Petit law? According to Dulong and Petit law, for all solid, especially metal, for all metal, molar specific heat capacity is almost fixed. For all metal, molar specific heat is fixed. तो एग्जामिनर लोग देखो चालाकी कर सकता है कि एक मटेरियल दे देगा, इसका स्पेसिफिक हीट इतना है, तो इसका कितना होगा, मास अलग अलग दे देगा, मॉलिक्यूलर वेट अलग अलग दे देगा. सो डोंट कंफ्यूज, मेटल का सबका मोलर स्पेसिफिक हीट ऑलमोस्ट सेम है, और इसका वैल्यू होता है 3R पर मोल पर डिग्री सेंटीग्रेड. 3R का मतलब क्या है, देखो अगर हम CGS में SI में जाएंगे 3 into 8.314 which is लगभग 25 जूल पर मोल पर केल्विन, और इसी को अगर हम एसआई में एसीजीएस में करें 1.99 लगभग 6 कैलोरी पर मोल पर डिग्री सेंटीग्रेड। तो ये जो है सेम रहता है सब मेटल के लिए लगभग, दैट इज कॉल्ड ड्यूलॉन्ग एंड पेटिट लॉ। ठीक है, okay, after that the next is thermal heat capacity, because ये सबसे क्वेश्चन रहता है thermal heat capacity। thermal heat capacity क्या है? अच्छा, one more important thing, yes, देखो, del Q is mc del T, so C is 1 by m del Q by del T. Similarly, capital C 1 by n del Q by del T, और नंबर ऑफ मोल जो होता है मास बाय मॉलिक्यूलर वेट। तो अगर मैं यहाँ पे इसको 1 by m करूं dq by dt, तो हमें क्या मिलेगा? m इंटू 1 by m dq by dt। अब देखो 1 by m dq by dt क्या स्पेसिफिक हीट कैपेसिटी, तो mc इज द कैपिटल C, ये है मोलर स्पेसिफिक हीट कैपेसिटी। अगर मुझे स्पेसिफिक हीट कैपेसिटी को मोलर स्पेसिफिक हीट कैपेसिटी में चेंज करना है तो मॉलिक्यूलर वेट से मल्टीप्लाई करना पड़ेगा। आई जस्ट गिव यू वन एग्जांपल, स्पेसिफिक हीट ऑफ वाटर इन जनरल, वाटर के लिए मतलब लिक्विड केस में 1 कैलोरी पर ग्राम होता है, 1 कैलोरी पर ग्राम होता है पर डिग्री सेंटीग्रेड। इसी को अगर हम मोलर स्पेसिफिक हीट में कन्वर्ट करें, मुझे मॉलिक्यूलर वेट ऑफ वाटर से मल्टीप्लाई करना पड़ेगा। वाटर का मतलब होता है H2O, तो 2 + 16 18, तो मैं अगर 18 से मल्टीप्लाई करूं तो 18 कैलोरी पर ग्राम के जगह पे हम अब लिखेंगे मोल। So in that way we can convert specific heat capacity into molar specific heat capacity, or the vice versa, molar specific heat capacity। अगर मोलर स्पेसिफिक को स्पेसिफिक में डिवाइड कर चेंज करना है, so divide by the molecular weight। Hope you understand that part। After that part, next is the thermal heat capacity। thermal heat capacity में क्या होता है कि it is represented by TH, that is dq by dt। तो अगर देखो dq by dt है, अभी अभी हम लोगों ने आपको मालूम है कि we can write it m into 1 by m dq by dt, that is the first thing, मतलब this, or you can write n into 1 by n del q by del t, so that is n into capital C also। okay, so basic idea is that thermal heat capacity मतलब del q by del t, the heat required to raise the temperature of a given body by 1 degree is called the thermal heat capacity। Next one, very very important, that is called the water equivalent। देखो वाटर इक्विवेलेंट क्या है, जब तुम किसी भी चीज को गर्म करते हो तो तुम क्या करते हो, एक कंटेनर लेते हो। सो मानो कंटेनर के अंदर में कोई लिक्विड है एंड यू ट्राई टू चेंज द टेम्परेचर, सपोज 50 डिग्री सेंटीग्रेड। सो बेसिकली नॉट ओनली द लिक्विड, द कंटेनर आल्सो चेंज द टेम्परेचर 50 डिग्री सेंटीग्रेड। तो अब इस 50 डिग्री सेंटीग्रेड कंटेनर को चेंज करने के लिए जितना हीट लगा, उतना हीट कितना अमाउंट ऑफ वाटर वो सेम 50 डिग्री चेंज करेगा। दैट मच अमाउंट ऑफ हीट, how much amount of water required to change the same range of temperature, दैट मीन्स वाटर इक्विवेलेंट का जो SI यूनिट है वो है kg. ये है अमाउंट मतलब मास, SI यूनिट है kg. Is it clear? Everyone, is it okay?
Yes, sir.
So let's try some numerical. देखो पहला क्वेश्चन है. Question is a certain substance has a mass of 50 gram per mole. As a certain substance has a mass of 50 gram per mole. That means basically it gives you the molecular weight. Okay, when 30 joule of heat is added to 25 gram of the sample, when 300 joule of heat is added to the 25 gram of the sample, when 30 gram 25 when 300 joule of heat is added to 25 gram of sample of this material, its temperature raises from 25 to 45 degrees centigrade. 25 to 45 degrees centigrade. Calculate number one thermal heat capacity. Calculate number one thermal heat capacity. Number two, specific heat capacity. Number three, molar specific heat capacity. Find करो तो फटाफट. TC का फॉर्मूला है del Q by del T. So TC is given 300 and del Q is then 25 to 45 माने 20. So how much you have? 15 joule per degree centigrade. You can write in degree centigrade, you can write in Kelvin, no issue. Achha, second one is the specific heat capacity. What is the formula of specific heat capacity? 1 by molecular weight, 1 by mass of the sample, and del Q by del T. So basically you already have del Q by del T. So you have to find out only the mass, but these are in joule per degree centigrade. The joule is in SI unit. As the joule is in SI unit, so this mass you have to convert it into kg. So mass is given 25 gram sample. So 25 into 10 to the power minus 3 into 50. So what you have 1000 into 15 by 25, 25 কত 100 400 15 30 30 600. Now the unit is joule per kg per degree centigrade. Or if you write in this one, if you put m is 25, then you have to write joule per gram. Okay, the third one is molar specific heat capacity. So the difference is n is the number of mole, that is mass by molecular weight. So amount of the sample is 20 gram, 25 gram, and molecular weight of the sample is 50 gram. So the number of mole is half. So 1 by n del Q by del T, that is 1 by 2 into 50, that is 30 joule per mole per degree centigrade. Is it clear, everyone? Is it okay? Hello?
Yes, sir. Yes, sir.
After that, the next very, very important thing is latent heat. So latent heat is mainly two types. One is the latent heat of fusion, one is the latent heat of vaporization. If we take water as an example, CGS and SI system. So in CGS system, or latent heat of fusion, what do you mean by fusion? Fusion means solid to liquid. So here you need 80 calorie, and here you need 335 into 10 to the power 3, that is joule per kg, and that is calorie per gram, if I'm right. Yes. And for latent heat of vaporization, what do you mean by vaporization? From liquid to vapor. So liquid to vapor, it is 540 to 260 into 10 to the power 3. Now, the most important part is here. Suppose for a solid, like ice, suppose we are starting from minus 40 degrees centigrade for m amount of suppose for m amount of water. So when we start from minus 40 degrees centigrade, so first this minus 40 degrees centigrade of ice become 0 degrees centigrade of ice. The amount of heat required, m, is the amount of water, amount of ice, specific heat of what you can say solid, means the specific heat of ice, you can say specific heat of ice, which is 0.5. If we use water, the ice of water, 0.5 calorie per gram. Now when it is at 0 degrees centigrade of ice, to convert this 0 degrees centigrade of ice into 0 degrees centigrade of water, what we require? Mass of ice, latent heat of fusion. So now after this Q2, latent heat of fusion, the water, ice converted into water at 0 degrees centigrade. Now water from 0 degrees centigrade move on to 100 degrees centigrade. 100 degrees centigrade. So this is Q3, mass, specific heat of water, and change in temperature, that is 100, you can say. Here the change in temperature is 40. Now this is 100 degrees centigrade of water converted into Q4, mass, latent heat of fusion. Now it is in 100 degrees centigrade of what? 100 degrees centigrade of vapor. Now from here, 100 degrees centigrade of vapor, the amount you want to take, suppose I want to take 400 degrees centigrade of steam. These are the super steam. Okay. So what about this Q5? Q5 is mass, then specific heat of vaporization, that is steam, that is steam or vaporization, 0.47 calorie per mole per gram into change in temperature. So here change in temperature 100 to 400. If you write, you can write it 300. So in that way, we can find out the latent heat. Everyone, you got it? हेलो हेलो, देखो कुछ छोटा छोटा क्वेश्चंस मैं दे रहा हूँ। जैसे फर्स्ट क्वेश्चन है, हाँ, you can try this question. पहला क्वेश्चन है, how many gram of ice, question, how many, let the m amount, how many gram of ice at minus 14 degrees centigrade is needed to cool uh, 200 gram of water from 25 degrees centigrade to 10 degrees centigrade. 10 degrees centigrade. Specific heat of ice 0.5 calorie per gram per degree centigrade. Specific heat of latent heat of fusion 80 कैलोरी पर ग्राम. ये बार बार दिया हुआ ही रहेगा, फाइंड आउट करो. अच्छा, now see, the question is 200 gram of water, 200 gram of water initially at 70 degrees centigrade, initially at 70 degree centigrade in a vacuum flux. Okay, एक vacuum flux के अंदर इतना water है, ठीक है. In a vacuum flux, water equivalent is W. Water equivalent of the flux is W. Water equivalent is W. When 50 gram of ice has been added, when 50 gram of ice has been added, when 50 gram of ice has been added and has all melted, the temperature of the flux become 70 degrees centigrade. So temperature becomes 70 to 40 degrees centigrade. Initial temperature 70 था. तो क्या हुआ, एक कंटेनर है जिसमें क्या है 200 ग्राम ऑफ वाटर है, एक कंटेनर है जिसमें 200 ग्राम ऑफ वाटर है और जिसका टेम्परेचर है 70 डिग्री सेल्सियस. इसमें हमने 50 ग्राम ऑफ आइस डाला. आइस डाला, टेम्परेचर नहीं बोला है, मतलब दे ऑल आर एट 0 डिग्री सेंटीग्रेड, all melted, and now the temperature of the system 70 to 40 degrees centigrade. Is it clear? When a further 80 gram of ice has been added, after that, now what is the temperature of the container? Temperature of the container is 40 degrees centigrade. And what is the water is there? 200 gram of water पहले से था और अभी 50 gram हो गया है. मतलब now the amount of water is 250 gram water and temperature is 40 degree centigrade. अब इसमें हम लोगों ने क्या किया कि 80 ग्राम ऑफ आइस फिर से ऐड किया. ठीक है, 80 gram of ice has been added and has all melted. The temperature of the whole become 10 degrees centigrade. Now from here the temperature of the whole become 10 degrees centigrade. Okay, neglecting heat loss by the surrounding से कोई heat loss नहीं हुआ. Calculate heat loss by the surrounding. 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 Calcul Calculate number one, latent heat of water. Calculate latent heat of fusion. Number two, specific heat of water is given. Specific heat of water is given 1 calorie per gram per degree centigrade. Acha. Also calculate the water equivalent. Done. Try this question, okay? And हम लोग कल अगर सब ठीक ठाक रहा तो कंटिन्यू क्लास लेंगे, मतलब 10 बजे से 11:30 बजे तक. Okay, so I'm stopping.